Hi, and welcome to Chapter 9, Section 1 for Math 127. This is the first of 4 videos. It's a new chapter, it's a new concept. So the first chapter we're going to have these 4 videos kind of going through the different concepts, explaining some definitions, kind of taking it slow at first. Section 9.1 is vectors in 2 dimensions. So first of all, we need a definition. So what is a vector? So a vector in a plane is a line segment with an assigned direction. So we've sort of seen some problems like this already, our bearing and heading problems, right? We're given a distance with like heading north 30 degrees east or something. So that is a line segment with an assigned direction. We're going to simplify it a little bit now by using this concept of vectors. So what we have is, we'll call this point A, which is our initial point. It heads off in some direction to some point B, which is our terminal point. And then we give these vectors names. So we'll call this one U. So this is vector U. We can signify this with the notation U with a little arrow over the top of it. So this symbol here, U with the little arrow, is the same as saying vector U, which means we have some vector starts at A, ends at B. Starts at an initial point, ends at a terminal point. The length is called magnitude. And this is denoted as initial point, terminal point with the little arrow. We could also call it just the magnitude of U if we've given it a name. So you can think of a vector sort of as displacement. So if you were just sitting in a boat and there was some current pushing you for a certain amount of time, where you started, where you ended, it's that displacement. That's what the vector represents. Now a nice feature of vectors, so let's look at an example here. Let's say I have this point A and some vector that gets me to a point B. So we'll call this vector AB. And I have another vector from B going to C. So we'll call this vector BC. Well, the nice thing, because again, vectors are just representing displacement. If I was to just go from A to C, so let's call that vector AC. Because vectors just represent displacement, AC is the same as if I take vector AB and add to it vector BC. Again, because vectors are representing an assigned length with an assigned direction. So I go from A to B, I get pushed over, then I get pushed upward. It's the same as if I was just pushed from A to C to begin with. So another term here for you. We have that if A is a scalar, So this is just a fancy word for a number that multiplies by a vector in this case. So if A is a scalar and V is a vector, then AV, the scalar multiplied by that vector, has magnitude so absolute value of A times the magnitude of V, and has the same direction as V if A is greater than 0 and opposite direction if A is less than 0. So, what does this mean? Again, this is sort of the issue with math. I know a lot where you get this big old definition, it really doesn't make any sense, but the concept itself is pretty straightforward. What it means is the following. Let's say we have this example. Let's say I have some vector V. If I have a scalar A that's 2, so I want 2V, well, it just means that it's twice the length. So if this is V, this would be 2V. It just multiplies that vector by 2, by the value of A, in the same direction. So V was starting out directly to the right, so I keep going directly to the right. I could also have fraction scalars, so 1/2 times V. So if that's the case, it's just going to be a length half of what the length of my original vector V was. And then lastly, if I have -1 as my scalar, so minus V, well, it's still the same length because -1, so 1 times V, this length is the same, but the minus sign means it goes the opposite direction. So now I have something that looks like that for minus V. So again, the wording, the definition of it, the concept, a little confusing maybe with words, but visually what does it mean? Well, it just means if I have 2 times a vector, it doubles it in that direction. If I have 5 times a vector, you multiply the length by 5, but keep going that same direction. So the next idea we're going to look at is vectors in a coordinate plane. So let's say we have our xy plane, or AB, and we have some vector. So we're going to represent our movement from the left or right to the left or right with the letter A. A is positive if we're moving to the right, negative if we move to the left. B is our vertical change. Positive if we're moving up, negative if we're moving down from our initial point to our terminal point. So by definition, so to go from the initial point to the terminal point, we move A units left or right and B units up or down. And again, this is all dependent on whether A is negative or B is negative. Then we would be moving left or down. So we denote this as the following. V is a B. So notice these little notation here. It's not parentheses. It's not parentheses AB. It's these little triangle brackets. That's telling us that a vector, if we're given a starting point, if we move A and B units left or right, up or down, that will get us at our terminal point. Another definition, if a vector V is represented in the plane with initial point P x1, y1, so this is the point x1, y1, and terminal point Q x2, y2, then our vector V can be represented as x2 minus x1, y2 minus y1. So for my terminal point, take that x value minus the x value of my initial point. That gives me a value for here in the beginning. And y2 minus y1 is my B value, which direction I'm moving, up, down, left, right. So let's look at an example. So we have the following. We want to first find u, my vector u, with initial point -2, 5, and terminal point (3, 7). And then a new question, if some vector v has dimensions 3, 7, so if this vector is sketched with initial point (2, 4), what is the terminal point? So two different kind of questions testing the same sort of concept, this vector idea of my movement AB within a plane. So let's solve number 1 to begin with. So we want to find the vector u, which in this case is going to be x2 minus x1, y2 minus y1. My x2 is my terminal point, so that's this guy here. So 7 is my y2. So -2 is my x1, +5 is my y1. We have to get this order right. If we screw up the order, if we screw up the math, we're going to be in trouble. So it's good to label them within the question. So u is x2, which is 3, minus x1, which is -2. And then y2 is 7 minus y1, which is 5. So that means u is 3 minus a -2 is like 3 plus 2, which is 5. 7 minus 5 is 2. So my vector u has dimensions. A is 5, B is 2, 5, 2. So no matter what initial point I'm given, if I add 5 to the x value, if I add 2 to the y value, that will get me my finishing point. So now let's solve 2. So this one's asking us a little different concept. It gives us the change. This is my A, this is my B. It's telling us that we're given an initial point of 2, 4. So we don't have to be super exact, just some point there. And then the vector is positive 3, positive 7. So what does that mean? It means we move 3 units to the right, 7 units up. And this, it wants to know, what is that guy there? What is that terminal point's coordinates? So what are we really doing? We're just taking the point we have, 2, and adding to it our A value, which is 3. And then our starting point 4, and add to it the B value, which is 7. Because no matter where we start, we're going to move 3 units to the right, 7 units up. So that gives us a point of 5, 11. So that would be our terminal point if our initial point is 2, 4, and the vector has dimensions 3, 7. All right, I'm going to erase this. If you need to catch up, go ahead and pause it. The last idea we're going to look at here for video 1 has to do with magnitude of a vector. And I sort of alluded to this at the very start of this video, and it represents the length of a vector. So the magnitude, or length, of vector v which has dimensions a, b, is as follows. Well, what is this representing again? Remember, we have some initial point here. We're moving A units left or right, B units up or down, and magnitude would be what? It would be the length of that solid line. So I'm sure you're sick of the formula by now, but I'm sure you can figure out, how do I figure out the magnitude of a vector? Well, it's just what? So the magnitude of a vector is the square root of a squared plus b squared. It's off of Pythagorean theorem again. If I want to know what's the length of v, what's the length of that solid line if I'm given a and b as my dimensions of the vector, it's just the square root of a squared plus b squared. So let's look at a quick example of that. Again, pretty straightforward, as much as we've been using Pythagorean theorem this semester, but just to get the concept of how questions are worded and so forth, it'd be something like the following. Find the magnitude of the following vectors. The first one, u is equal to 2, negative 3. And the second one is 5, 0. So if you think you want to take a shot, go ahead and pause. If you want to see me work the first one, then try the second one, you can do that as well. So I'm going to work the solution in number 1. So if we want the magnitude of u, it's just the square root of what? 2 squared plus negative 3 squared, which is square root of 4 plus 9, which is square root of 13. So the magnitude of u is square root of 13. Number 2, same idea. If you want to try it first, go ahead and pause. Solution in number 2, the magnitude of v is the square root of 5 squared plus 0 squared. So that's the square root of 25, which is just 5. So that's it for video 1 of section 9.1, kind of an intro to vectors, what they represent, how we write them, how do we find magnitude. Come on back and we'll tackle video number 2 for section 9.1.